Hello friends, welcome to Study Bay Technologies. In this section of chemistry, we will talk about reactions and chemical equations. So let's go ahead and start our topic. Now, first of all, how to check if any chemical reaction has taken place or not. So it actually completely depends on your observation here. What kind of observation and what you need to look out. Like number one, you need to check for the change in state. Then the second observation is which is required over here is like if there is any kind of change in color of reactant, right? Or if there is any kind of evolution of gas, some gas is getting evaluated or like that of gas, and then at last we have change in temperature, like if the body is getting colder and or heat getting warmer or something like that. Okay, so depending on the reaction in a sentence form, it's quite a long process. If you try to describe a reaction in terms of a sentence or a paragraph, it will be very complicated and a quite difficult form actually. However, it can be written in a shorter form, and the simplest way to do this is to write in a form of a word equation, and this equation is called as your chemical equation. Okay? So, this chemical equation actually consists of two parts. First one is your reactant, and the second one is your product. Reactant and product. Okay? So, the substance that undergo a chemical change in a chemical reaction, these are called a reactant. And a new substance formed during the reaction is a product. Okay? Now the question is, there is a term something called as a balanced chemical equation. Balanced chemical equation. So you might have studied in your previous classes, like if we have an equation combining two different atoms or I mean kind of elements, we can get a third element. It's like that, right? By mixing carbon dioxide and water, we can get the constant compound. By mixing hydrogen and oxygen, we get H2O, which is water, something like that kind of environment. So, as per the law of conservation of mass, the mass can neither be created nor be destroyed in a chemical reaction. Okay, that is the total mass of the reactant is equal to the total mass of your product. That means like the number of atoms of each element remain the same before and after a chemical reaction. Okay, now let me take one small example here. Let us discuss it. It's like, let's say I'm going to write a small chemical reaction here. It's a small chemical equation over here. Let's say we have something like zinc. Okay, I'm going to react it with H2SO4. Okay, you know that this is your sulfuric acid, 2SO4. Fine. Now, what is the product? The product is zinc sulfide, ZnSO4 plus your hydrogen. Right? Now, if we check out, I mean, how many elements are there before the reaction, how many atoms are there after the reaction. So let us highlight this. Something about zinc first of all. So before the reaction, it was one atom of zinc, and even after the reaction, we have only one atom of the zinc. Right? That means the zinc is completely balanced here. Now let's talk about hydrogen. This hydrogen having two atoms here before the reaction, and in the similar way, after the reaction also, this hydrogen has four atoms. Right? Then we have sulfur, that is again one atom. So yes, after the reaction also it has one atom. And we have four atoms of oxygen. That means even after the reaction also we have four atoms of oxygen. So this means this given equation is completely balanced equation. Right? So there are a few different ways like how we can balance a given equation that you might study in higher classes also. So there are some methods like kind of hit and trial, which we will follow here because in junior classes we will be using normal kind of reactions. We can use hit and trial method to balance a chemical equation. Then we have kind of oxidation and reduction method, right? Then we have ion electron method. These are the few methods through which you can balance a given chemical equation. But in this class, we will talk about generally hit and trial kind of scenario. So let's go ahead and let's take a few examples so that if you remember them at least, or you just learn the concept how to go ahead, you will be able to balance any kind of equation, right? So like before going to balance, before start or before attempting any equation for balancing, just remember a small concept here. Like first of all, try to balance the metals. Okay. After that, try to balance the non-metals. Okay. After that, try to balance the oxygen part which is related to oxygen. And at last, you can try to balance the hydrogen. Fine. So let me take one example here. In this case, like let's say, um, yeah, let me use this here. Yeah, let's say I'm going to use magnesium nitrate. Let's say that is a method for preparing ammonia as well. So if you remember this, the ratio is magnesium nitrate is Mg3N2. Okay, Mg3N2 plus we have to react the same with water, that is H2O. Fine. Then what will be the output? It is magnesium hydroxide, that is MgOH2. Fine. And the output will be ammonia, that is NH3. Now this ammonia will flow away as being a gas. Fine. Now let us check if this given equation is balanced or not. So first of all, we have a metal, that is magnesium. It's having three atoms over here before the reaction. But after the reaction, it is mentioned only one element here, one atom here, one Mg, right? So let's do one thing. Let me make it 3 here, right? So now the 3 Mg and 3 Mg is balanced now. 3 atoms of magnesium and 3 atoms of magnesium. Fine. So remember that, like while balancing any equation, like if there is any change in any element, just go to the step one and check out if everything is balanced or not. Okay. So I have balanced this magnesium. Now the next step is about non-metals. Let's say this is the nitrogen. So here we have two atoms of nitrogen, but here we have only one atom of nitrogen, right? So let me put two over here. Fine. So you can see that now the nitrogen is also balanced. Fine. The next one is something about your oxygen. All right. So before this reaction, we have only one atom of oxygen, and now here, like two oxygen and two multiplied by three, that is six oxygen atoms are there. Fine. So six oxygen atoms are there, and here we have only one, so we can put six H2O. Fine. And at last, we have to manage this hydrogen atoms. Hydrogen atoms is again 2 multiplied by 3, that is 6, and here also 2 multiplied by 3, that is 6. So 6 plus 6, that is 12, and here also we have 12 hydrogen atoms. Right. So now if we check again, like magnesium, it has 3 atoms. Here we have 3 atoms of magnesium, that's completely balanced. Then we have nitrogen. This nitrogen is again, we have one atom here, sorry, two atom here, and so we have two atoms of nitrogen over output also. Then about the oxygen, we have six atoms of oxygen here, and here also we have six atoms of oxygen. And at last we have hydrogen, we have 12 atoms of hydrogen, and here also we have 12 atoms of hydrogen, and that's why we can say that this equation is completely balanced. Alright? This is how you can proceed to balance your given chemical equation. Alright? In a similar way, let's see a few more examples, one or two more examples. Let me show you so that you can get more acquainted towards this kind of method. Okay, so let's talk about aluminum setup, that is Al4, Al4C3. Okay, plus we have water. Let's say I'm going to make a reaction of this Al4C3 with water. Fine. Now the output is methane, first of all. Then we have the output is aluminum hydroxide, AlOH3. Fine. Al4C3 plus H2O, the output is methane, and AlOH3 is aluminum hydroxide. Now, again, the first step is we need to check the metals first of all. So the first metal over here is aluminum, right? So in aluminum we have four atoms here, and here with the output we have only one atom. So of course I have to put four over here at the output. Fine. So you can see that at the reactant part we have four aluminum atoms, and at the output part also we have four aluminum atoms. Fine. Next one, let's talk about a non-metal setup, that is the carbon. We have C3, that is three atoms of carbon here, and here we have only one atom of carbon. So let me put it three times CH4 as well, right? Again, let's check if everything is fine, like four aluminum atoms, that's fine. We have three carbon atoms, and we have three carbon atoms here also. Now let's talk about oxygen setup. So here we have 12 atoms of oxygen, and here we have only one atom of oxygen. So let's make it 12 here. Okay. Now your oxygen is also balanced, 12 atoms of oxygen and 12 atoms of oxygen here as well. Now let's talk about hydrogen. That is 12 hydrogen. 4 into 3 is 12 and 4 into 3 is 12. And we have 12 into 2 as 24. Here we have 24 atoms of hydrogen. Let me write it. 24 atoms of hydrogen here. We have 12 atoms of hydrogen here. And we have 12 atoms of hydrogen here. Right? So the combination is again 24 atoms of hydrogen in the reactant and 24 atoms of hydrogen in the product as well. So this is how you can balance your given equation, and this means this equation is as well the completely balanced one. Right? Now let me take last example here, how we can proceed for this one. And let me take this one as the last example. I'm going to take it. So, one second. Yeah. Now I have C2H6, ethane, this one, C2H6, this is ethane plus, let me burn it, that means I'm going to combine it with oxygen, right? Now the output is carbon dioxide and water, that is CO2 plus H2O. Fine. Okay, so now let's balance this equation. So first of all, we have carbon, right? We don't have any metal over here, so not to worry. We have a carbon here that is having two atoms. So let me add two atoms over here for carbon, right? Now carbon is balanced. Fine. The next step is balancing the oxygen. Okay, that's good. So we have two atoms of oxygen here, and 2 to the 4 plus 1, 5. 5 atoms of oxygen are here. Okay, so the point is like you have to make sure that two atoms of oxygen should be balanced with the five atoms of oxygen at the output. Well, so not to worry, let's have it like 5 by 2, right? Now, if you make it 5 by 2, what will happen? Like this 2 will be cancelled out by this, so 5 atoms of oxygen will be equal to 5 atoms of oxygen at the output level. Okay, well, if you use this fraction level, it doesn't seem good actually. So now let me do one thing. Let me, remove it. Let me remove it and make it little bit sensible here. So instead of that, I just multiply the entire system, entire equation with 2, right? Then what will happen? This will become 2, right? 5, this will remain 5 because 2 will be cancelled out. Okay, now this will become 4. If you multiply the entire equation, this will become 4. Okay, and this will become 2H2. Fine. Okay, now let's see. As I already told you, like if there is any change, you need to go back to the step number 1 and check if everything is fine. Okay, that's good. Like two atoms of carbon, and we have four atoms of carbon over here. That means that carbon is balanced. Now, if we talk about the oxygen, we have 10 atoms of oxygen here, and we have 4 to the 8 and 2, 8 plus 2, 10 atoms of oxygen at the output also. So the oxygen is also balanced now. That's everything is okay. Now let's talk about the hydrogen. Right here we have 12 atoms of hydrogen here, and here we have just 4 atoms of hydrogen. Fine. Okay, that's again a problem. Like this time we have 12 and here we have 4. Alright, so we have to convert this, make sure that this 4 should be get into the this one, it should be balanced by 12. So 12, if we have to make it, we have only one option. Just instead of 2, we can make it 6. Right? Now we have 12 atoms of hydrogen here and 12 atoms of hydrogen here as well. So hydrogen is balanced, no doubt. But if we try to figure out for this, kind of oxygen, so this is 8 and this is 6, right? So 8 plus 6, 14, right? So we have 14 atoms of oxygen at the output and only 10 atoms of oxygen at input. So again, simple, very simple step we have to take. Instead of making it 5, we can make it 7, right? Simple, little bit complicated actually. I cannot say it's, but the thing is like at least you can learn it. So now let's check it like about the carbon first of all. We have 4 atoms of carbon here. We have 4 atoms of carbon at the output. We have 14 atoms of oxygen. We have 4 to the 8 plus 6, 14 atoms of oxygen at the output. We have 12 atoms of hydrogen. Unfortunately, we have 12 atoms of hydrogen also. That simply specifies that this particular equation is completely balanced. Fine. So this is how you can apply your hit and trial method. Make sure that you start with the metal, then non-metal, then oxygen part, and then finally the hydrogen part. Okay. So if you have any question, any doubt, feel free to let me know by writing your comment on the comment box. And if you like the video, please share and subscribe the same. Have a nice time ahead and take a very good care of yourself. Bye bye.